You are here for the It's a Bird, It's a Plane educator webinar hosted by the Arizona Game and Fish Department. Let me do a quick little introduction. For some of you, this will be a little bit of a review. You've been to a couple of these, and we're actually going to do a quick survey for you guys in a minute here. First, we're the Arizona Game and Fish Department. If you're not familiar with us, we are the state government agency responsible for managing all of Arizona's wildlife species. Many people interact with us through the hunting and fishing licenses, the sale of those. You go buy a hunting and fishing license at the store. We're the ones that issue those licenses. We're the ones that enforce those regulations and those laws associated with hunting and fishing. But we are more than just hunting and fishing. We are responsible for all of the wildlife. So even those that you cannot legally hunt or fish. That includes endangered species, threatened species, and even those that don't fall into those categories. It's our responsibility to just sort of make sure that they're all doing okay at a population level. If there's not enough of those species, we sort of implement policies and regulations and strategies to bring those population levels back up. And obviously, if there's too many of a population, which can be just as bad because you can have an animal population that can overuse its resources. And so we want to prevent that from happening as well. So if there's too much of a particular population, we also implement policies and strategies to take care of that. And that's where hunting and fishing typically comes in. Even though we're a government agency, we are not funded like your typical government agency. We describe it as being a user pay model. And so we are funded primarily by the users of the resource. And that's where like I said, the hunting and fishing licenses come in. People buy a hunting and fishing license. The money from that, the sale of those, goes directly toward wildlife management and conservation. And then and then we also have an excise tax on hunting and shooting and fishing equipment and boating fuel and some other things like that. So again, when you go buy ammunition to go hunting, when you go buy a fishing rod, when you go buy various things like that you're going to do to engage in that sport, then you're also contributing money towards wildlife conservation. And then finally, I am funded through something called the Heritage Fund, which comes from our state lottery. So when you buy a lottery ticket, a portion of that money goes towards preserving Arizona's wildlife heritage, which is used for some of our species that can't be legally hunted and fished. Things like bald eagle management, Mexican wolf conservation, black-footed ferret reintroduction, and then there's a certain portion of that money goes towards what's legally defined in statute as environmental education. So everything that you see that's offered today, all the resources we provide, are being funded through the Heritage Fund. My name is Eric Proctor. I'm the Wildlife Education Coordinator for the Arizona Game and Fish Department. I've been in that position for coming up on 11 years now. Prior to that, I was a middle school science teacher. I taught 7th grade science at both the Littleton School District here in the Phoenix area and the Kyrene School District, also in the Phoenix area. Chandler is where I was coming out of for that. I kind of work behind the scenes. It's my job to do teacher professional development, like these webinars and in-person webinars, and I come out to districts and do in-services, and then I also do curriculum development. So it's my job to find and work with you guys on finding unique ways to bring wildlife concepts, wildlife issues into the classroom. Let's go ahead and get started then. What I want to do is I'm going to throw up a quick little poll. So in the poll, you should have the option to choose. What I want to do is get an idea of what level of student you typically are working with. You can answer more than one if you do that, but I just want to get a rough idea of my audience here. This is another way that I can sort of engage with you. And in just a moment, I will close the poll and I'll show you guys the results as well. All right, I'm going to go ahead and close the poll. And then I'm going to share the results so you guys can get an idea of who is here. And you can see that the majority are sitting right there at the elementary and middle school level, which is good. What you're going to find is that this is an interesting one because some of the content we're going to be dealing with is actually intended for an elementary audience when you look at the standards, but some of the other content is at a little bit higher level. Some of the stuff I am working at towards probably an upper elementary, middle school, high school level, but obviously, as you guys know as teachers, you can modify and make things appropriate for whatever is going to work for you. All right, so let's continue. What we're going to do is we're going to start with the Wright brothers, and that's where our discussion is going to come from because that's really where the inspiration for this type of activity came from. Orville and Wilbur Wright grew up. They were in Dayton, Ohio when they grew up. You can see little young pictures of them there, and of course as they got older. Okay. They lived right around the turn of the 20th century, and that's where most of their work was being done. If you're not familiar with the Wilbur and Orville Wright, this is the house that they grew up in Dayton, Ohio. What they did to make a living was they actually worked for they owned the Wright Cycle Company, and they worked on bicycle repair, building bicycles and things like that. And that actually became very beneficial. They used some of that to eventually go on to build the first manned aircraft. I like to look at the Wright brothers, even though they were not necessarily trained as scientists, they were bicycle repairmen. They were, in my opinion, oftentimes the epitome of what a scientist is. And you can explore their writings. They took lots of diaries, they took lots of journals, and when you go through that, you can see the nature of science at work. And so it really allows us to address some of those standards that address how is science done, and it's a great illustration of that. As you go through their writings, some of the things that you're going to find, some themes that are going to come out of that, you can see in there. There's a big one on collaboration among scientists that we'll talk about in just a second. They talk about the importance of observations and learning from and building on past discoveries. So again, some of these key elements of science and what makes science science. And then, of course, you see a lot of unselfishness, which ties in with their collaboration. And there's actually some pretty humorous parts in some of their journals and their diaries. To give you an example of some of these things that we're talking about, is the collaboration and unselfishness piece. And this is from a letter that Wilbur Wright, one of the brothers, wrote to another scientist at the time who was also trying to solve the puzzle of manned flight. See, at this time, the beginning of the 20th century, that was the Holy Grail, for lack of a better term. That's what people wanted to do. So there were a number of people around the world that were trying to figure out, how do you put man on an airplane and get them to fly? What I found so fascinating as you go through their letters and their diaries is that although the Wright brothers were competing with all of these people, there was this sense of camaraderie. They liked to share. And this is just one example. This is a letter that Wilbur Wright wrote to one of the other people who was competing with this and trying to do the same thing that they were doing. And you can read it right there. I'll read it out as well. I will proceed to describe the plan and apparatus it is my intention to test. In explaining these, my object is to learn to what extent similar plans have been tested and found to be failures, and also to obtain such suggestions as your great knowledge and experience might enable you to give me. I make no secret of my plans for the reason that I believe no financial profit will accrue to the inventor of the first flying machine, and that only those who are willing to give as well as to receive suggestions can hope to link their names with the honor of its discovery. So I found this fascinating. One, we see the unselfishness. They're not interested in making a profit from this. Very simply, they could have patented the idea and probably made a lot of money once they did it, but that wasn't their intent. They felt that they were doing this for the greater good. Now, eventually they went on to form their own airplane company, but the whole concept of manned flight and what they were able to do, they weren't interested in patenting that and making money off of it. It was just, they felt it was for the betterment of humankind in general, which is what a lot of science does. But you can see that this idea that they acknowledge that they're not scientists, that they're not necessarily the experts at this, so they were consulting experts, and actually the scientists actually wrote back to them, and these guys corresponded quite a bit, and there are a number of letters back and forth between these types of people, which I think is fascinating, and you can document, all this stuff is documented. Now, that's some of their letters. What I want to do very, very quickly here is take a look at some of their diaries, and this is a sample of a page from one of their diaries, in one of their journals. And what it shows is the extent that they used to observe nature. What they realized was that if they were going to fly, the best thing to do was to learn from the experts. And in this case, the experts weren't humans, they were animals, specifically birds. So they spent hours and hours and hours just observing birds, specifically buzzards, okay, or vultures as we call them on this side of the country. And so I know it's hard to read that because it's in their handwriting sometimes, and if you can't, but I'm going to pull out a couple features here. First one right there is that says no bird soars in a calm, and so that's something that they've noticed after hundreds of hours. They basically were able to notice that when it's calm out there, when there's not really a breeze or a wind, the birds aren't soaring; they're flapping more. They have to expend more energy, and so that was an important observation to them. And then, of course, here's another one, and this one is probably one of their more important ones, and we'll see why in just a second here. But you can say, thus a buzzard soaring in the normal position will be turned upward by a sudden gust. It immediately lowers its wings much below its body. So they were talking about the wing design, and on the left side of that circle, you can see they actually started illustrating what this looked like. They have the wings up in a V, and then just below the red circle, you can see that the wings come down a little bit. They're describing this stuff, and this is a key feature, and you'll see this in the next journal entry as well. A lot of people at the time, that was one of the biggest issues they had is, okay, we can get somebody up in the air, but what do you do when there's a gust of wind? The weather, the wind currents aren't going to be consistent. So when you get up there, how are you going to deal with this inconsistency? And a lot of people were trying to do it with changing the center of gravity and doing all these types of things. And the Wright brothers realized that that's not what you do. There's other physical things that you need to do. It's a very active process. This is then that same letter that Wilbur Wright was inquiring about, sort of the information that's already been known. This is he was sharing some of his observations with the other scientists. And this is where it gets really, really kind of fascinating in some of the things that I had just mentioned. My observations of the flight of birds convinced me that birds use more positive and energetic methods of regaining equilibrium than that of shifting the center of gravity. So they weren't doing what everybody else at the time was trying to do. Everybody else at the time was trying to figure out solving this problem of wind and the inconsistencies in the air by changing somebody's center of gravity. If we could shift and we could move a person and we could do this and we can have them lay this way when this happens, then we can take care of this. And it wasn't working. And the reason why, because that's not what the birds do. They do something else. And this was the key part of their design. This was probably their most important discovery they made. And this is how they started to design those. My observations of the flight of buzzards lead me to believe that they regain their lateral balance when partly overturned by a gust of wind by a torsion of the tips of the wings. So what they did was they learned to twist part of their wings to deal with the inconsistency that they were going to face in the air. And that was key. And that's what they started to do. They developed this sort of wiring system inside their airplane that they could tug and pull on different parts to twist the wings of their airplanes just ever so slightly to deal with that. And no one else was doing this at the time. So this is setting the stage for how do we learn from nature, which is really the focus of this workshop, this webinar that we're taking here, is how can we learn from the experts, in this case, the birds? So to get there, though, I want to spend just a little bit more time with the Wright brothers, because this is kind of fascinating and some interesting stuff that you can add into some of your lessons here a little bit. I want to talk first about why Kitty Hawk. As I mentioned, the Wright brothers were from Dayton, Ohio. Dayton, Ohio happens to be about 700 miles from Kitty Hawk. And if you're not familiar, Kitty Hawk is where they actually tested the airplane, and that's where they eventually achieved the first manned flight. So why? This is 1900, basically. Over 100 years ago, it wasn't as easy to move 700 miles. And they were doing it on a relatively regular basis. Every couple weeks or so, they were packing up everything in Dayton, Ohio, and then they were going to spend a few months down in Kitty Hawk, and then they were going to head back to Dayton, Ohio. So the question is why? Why would they go through all this effort? Why don't they just do it in Dayton, Ohio or somewhere close? Can't they go up to Michigan and do pieces of that? I'm sure they could find some stuff. So the question is why Kitty Hawk? And so we're going to deal with that. We're going to go back in time a little bit. This is where I'm going to have you guys interact here. I want you to pretend that you are the Wright brothers back at the turn of the century. You've been studying flight. You've been observing birds. You're there. You are ready to test some of your ideas. Okay? You want to develop this motorless airplane and get people to fly. But you need some place to run the experiments. If you're going to build an airplane and you're going to test it, what type of site would you look for? And so in either the chat feature, if you have the chat feature, which I understand a lot of you have said that you don't, or in the question section, what I want you to do is jot down some ideas. What are some things that you think would be important to look for if you were the Wright brothers and you were testing the first airplane, your first ideas about an airplane? What would you start to look for? So I hear a number of people saying open space, constant stream of airflow or wind, so having a consistent wind, a place that has a soft landing spot, absolutely, flat land, wind again, room to move, flat grounds, air currents, bird travel in time, consistent predictable winds, good. Cliffs, so an elevation change, Now what we're going to do is I'm going to show you some pictures of Kitty Hawk. Now these are actual pictures that the Wright brothers took or people that were working with them at the time took. Okay, so this is, when we talk about social studies in particular, this is an example of a primary source document that you can bring into the classroom. Now I should mention that you're going to have access to all these pictures. You're going to look at the pictures, and there's going to be 4 pictures, and they are pictures of different angles of Kitty Hawk. And all I want you to do is look at them and see if they fit your ideas. Write down some observations. What do you notice about these pictures of Kitty Hawk, and do they fit with the original things that we were just talking about? Okay, so here's the pictures. And then when you have some observations, go ahead again to put them into the question box, because it seems like that's where everybody is interacting with. So let me go ahead and switch this over. And here are pictures of Kitty Hawk taken by the Wright brothers or their friends. While you're answering or looking at that, there's a couple things you'll note. You'll notice in the upper left-hand corner picture, there's a couple tents, and then you'll also see a tent in the lower right-hand corner. That is the actual tent that the Wright brothers were working in. That's kind of, for lack of a better term, that was the hangar that they had built to store their airplane in. Mia talks about that as a very open area, lots of wide open spaces, soft level ground. It's near the ocean. You see some water in there, so you're probably going to get some breezes off of the ocean. There's a little bit of elevation change. You can certainly, in the upper right-hand corner and in the lower left-hand corner, you can see sort of a hill that's there that they could certainly run some stuff as well. Does seem to have a windy appearance. It's hard to tell exactly, but you definitely have some of that stuff. So it fits a lot of the things that you were looking for, right? That you guys said. And that's exactly what the Wright brothers were saying. And in fact, in that same letter that we talked about that Wilbur Wright was writing to the other scientist, he asks very specific questions and says, this is what we think we need to run. Do you have any suggestions? And it was actually that other scientist that suggested Kitty Hawk. They weren't really familiar with the area. It was the other scientist that directed them to go check out Kitty Hawk. So I think that that's really cool. Again, we're seeing this collaboration. Here's these guys were competing. They were trying to do the same stuff, yet they were still willing to share these ideas and help each other along because they knew in the end it just improves everything. So I think that that was really cool. Okay, so I just threw that in there a little bit to get you thinking. There's a lot you can do with the Wright brothers, but I want to make sure that we move a little bit beyond that and look at what are we doing today? How are we building on the ideas of the Wright brothers? They showed us that we can learn from nature, that if we observe animals that are already doing what we want to do, then maybe we can learn from them and implement similar strategies. So now what we're going to do is we're going to look at some airplanes, or aircraft, I should say. On the next slide, there's going to be 4 aircraft. 3 of them are airplanes, and 1 of them is a different type thing. What I want you to do is just take a look at them. Okay. You don't need to write anything down at this point. You don't need to put anything in the chat. All I want you to do is think about looking at them and saying, what is the purpose of that airplane? And how do the wings help it? You all know, if you've seen airplanes at all, that many different airplanes look very different from each other. And so there's a reason for that. Their appearance fits their purpose, particularly with the wings. So all I want you to do is start thinking about that when you see these 4 pictures, because the next step then is you're going to try to match up those airplanes with some other animals here. So here's the aircraft that we're talking about. In the upper left-hand corner, you see a helicopter. In the upper right-hand corner, you see a P-51 Mustang. Then you see a bomber in the lower left-hand corner, a long-range bomber. And then you see the Concorde in the lower right-hand corner. So look at those, observe them a little bit, note some of the differences in their wing design and why they might have different wing designs. I'm going to leave this up for just a second while you just sort of observe. Now what we're going to do is we're going to compare these to birds, because all of those aircraft were designed with a very specific purpose. And when engineers went to design them that wanted an aircraft to achieve that purpose, they again did what the Wright brothers did and looked at nature. And they said, what birds act similarly to our goal, our objective of what we want out of an airplane, and how can we learn from their wing structure and their wing design to build our aircraft? Now, I say that recognizing that it is not just the wings of a bird that help them fly, but that's what we're simplifying it down for the purposes of that today. Okay? So what I'm going to do is I'm going to show you 4 pictures of birds. And you'll see just a sort of a profile shot of the bird, so you'll see their head just to show you what they are, and then you'll see a silhouette, a flying silhouette of that bird to give you an idea of what they look like in flight, so you can see their wing structure much like you could on the airplanes on the previous slide. Based on their wing structure and the purpose, what I want you to do is match each bird with one of the aircraft. So there's 4 aircraft and there's 4 birds. Each one matches up to another one. Okay, and so that's all I want you to do for the purposes of this, is to match them up. And so I'm going to show you the birds, and then we'll go through them one by one, and I'll ask you then to comment as we go through each bird and tell me what plane does it match up with. Okay, so here's the 4 birds we're talking about. If you're not familiar with them, just like I did with the aircraft, in the upper left-hand corner, we are talking about the peregrine falcon. In the upper right-hand corner, we're talking about a hummingbird. In the lower left-hand corner, we're talking about a turkey vulture. And in the lower right-hand corner, we are talking about a Cooper's hawk. I selected these ones because they're all, at some point in their life, they are found in Arizona. We have all of these species of birds coming in Arizona. They might migrate out. Some of these are going to migrate out, but at some point, all of these birds are in Arizona. That's why I selected them. Being part of the Arizona Game and Fish Department, we're interested in local wildlife. Okay? There are other examples you could certainly use. Okay? So thinking about those 4 birds, in just a second here, I'm going to want you to, we're going to start thinking about what aircraft they match. And you're going to try to tell me. So remember, we have the peregrine falcon, the hummingbird, the turkey vulture, and the Cooper's hawk. And then the airplanes we had, the aircraft we had was a helicopter, was a P-51 Mustang, was a bomber, and then the Concorde. Those are the 4 aircraft we're talking about. So you're going to match up one of those with one of these birds. So let's start with our first bird. We went so far. So I ruined the first one for you because it already went through. The hummingbird matches up with the helicopter. The trick now is to figure out what is the purpose. They both fly very similarly. What does their wing design help both of these, both the hummingbird and the helicopter do? What is unique about a helicopter that most other aircraft, and for that matter, hummingbirds, that most other birds can't do? And it looks like we've got some correct answers here, exactly right. They can hover. Okay? Both helicopters and hummingbirds can hover, and that's something that we don't see with most of the aircraft. And in this case, it acts because in the helicopter you have those 2 different rotors there, and they can work independently, basically, as can the wings of the hummingbird can work independently, which allows them to hover. And so we see that in here. Let's take a look at our next one, the peregrine falcon. Which of the aircraft does the peregrine falcon most resemble? Which one would we have modeled after the peregrine falcon? Got a couple answers coming in. I'm going to give you guys just a second there to throw some thoughts out there. Okay, some people seem very sure, and other people are sort of with a question mark, not quite sure. And in this case, some of you are correct. The peregrine falcon most matches the Concorde. And what we see in both of those is they have angled and pointed, or even in some cases, a triangular shaped wing. What does that do? Both of these, the peregrine falcon and the Concorde, are known for speed. If you're not familiar, right now the peregrine falcon is for the most part described as being the fastest animal in the world. Okay? It can reach speeds in excess of 200 miles an hour. It does that not during normal flight, but when it's hunting. If you're not familiar with peregrine biology, what they do is they hunt other birds and they hunt them in flight. And so what they'll do is they'll go really high up in the air, or they'll go off the edge of a cliff, and then they enter what's called their stoop. And when they enter their stoop, they tuck their wings in, and they basically look like a small flying missile, and they dive straight down. It's that dive that's called a stoop, and that's the time that they can reach speeds in excess of 200 miles an hour, and then they plow directly into the animal, into the bird that they're hunting. Basically shocks the bird, knocks it out. And so we looked at that and said, what makes a peregrine falcon go so fast? We looked at the triangular design of it and said, well, maybe we should do that. And if you start looking at some of our fastest aircraft, the Concorde being one, but other ones we haven't talked about specifically, but the SR-71 Blackbird has a triangular shape. The space shuttle, if you take a look at the space shuttle, which travels at extremely fast speeds as well, it has that triangular shape. So it helps with air resistance. So it's very, very effective. Lena actually makes the point that if you ever get the chance to see a peregrine falcon, do that. It's a fascinating experience, and I'm sure you can find some videos of it on there. Peregrines in general there's a fascinating story associated with them of survival and recovery. They were endangered at one point. They're in the process of sort of getting their populations back, and a lot of it is on their own. We're not doing it. There's not I wouldn't say there's necessarily peregrine reintroduction programs and things like that. What the biggest thing that we did as humans is we stopped using DDT, and DDT was affecting their eggs just like it was for eagles and some of the other birds. Once we stopped doing that, we sort of gave the peregrines a fighting chance. Now, the advantage that peregrines have is that their biology actually fits very nicely with what people do and on the human landscape. As I mentioned, they eat birds, they hunt birds, and they also like big canyons and things like that they can dive down from. Well, the one thing that humans built a lot of, we didn't build canyons, but we built a lot of skyscrapers in the middle of our cities. And the other thing that cities have a lot of is pigeons. And so a lot of these peregrines have started moving into cities. And in fact, there's a mating pair of peregrines in Phoenix, in downtown Phoenix. There's cameras on a couple of different ones across the United States. So that's kind of cool. It's kind of a neat story. They're starting to come back slowly, which is really kind of nice. All right, so let's take a look at our next one. Turkey vulture. We have only two airplanes left. So we've already done the helicopter and we've done the Concorde. So of the two that we have left, what does the turkey vulture most resemble? A couple of you have indicated that you think the turkey vulture most resembles the bomber. And you guys are correct. This is a long-range bomber. Okay? The intent was to fly long distances and be able to then bomb enemy targets. Okay? In order to do that, they needed to be able to conserve energy as much as possible. And so what they did was they looked at birds that do a lot of soaring, because when birds are soaring, they're not expending as much energy. They're not flapping their wings and using their energy. And so they looked at long-range soaring birds, the turkey vulture being one of those. And when we look at a turkey vulture's wings, they have very long, broad wings. Okay? Those long wings that are sometimes larger than the length of their body allow them to pick up air currents, thermals, those types of things a lot easier, and so that they don't have to expend as much energy. And so we can do the same thing when we're looking at long-range flying aircraft. They have these really long wings that allows them to sort of glide a little bit easier and not use as much fuel, so they can conserve energy and travel further distances. Okay. And of course, that leaves just one more. Long, broad wings we've already talked about, used for soaring. And our last one is the Cooper's Hawk. You guys remember what the last airplane is? Mustang, Spitfire, all those different types of ones. If you're not familiar, this is a dogfighting type of aircraft, needs to be very maneuverable. And what we see with the Cooper's Hawk and with the Mustang is that they have very short, more rounded type wings. Those shorter wings give it the maneuverability to make quick turns, quick cuts, to weave in and out, and that's what we see with the Cooper's Hawk. Okay, the Cooper's Hawk is another bird like the peregrine that hunts other birds, but it doesn't always do it in open spaces. The Cooper's Hawk is often going to be traveling through trees and has to be able to maneuver around that. Okay, so they looked at animals like the Cooper's Hawk and they said, what is unique about its wings compared to other birds? And they realized that their wings are a little bit shorter. They're a little bit more round. Okay, and that gives them that maneuverability. And so when we were designing aircraft that are designed to be dogfighting aircraft, to be fighting in air, we needed to look at what that type of wing design, and so we see shorter wings compared to, if you compare that to the bomber that we had before, which had really long wings that were longer than the length of the body. That's not the case of this Mustang here. So we're just about to wrap up. What I wanted to do is share this with you. You can't click on any of these right now, but again, this will be provided to you in a follow-up email. There's a number of links that are going to give you all sorts of information. The first few links that I put up there are all about the Wright brothers, and there's some fascinating things that you can get to them. There's the Library of Congress, which I highly encourage you to check out and spend some time at the Library of Congress's website. They have lots of resources, primary source documents, photos, and journals, and all kinds of things related to all sorts of historical events. but they also theme a lot of them together, and they put basically exhibitions together, and they've put all of the Wilbur and Orville Wright stuff together in one location. So you can get copies of their diaries, and you can get copies of their letters and newspaper articles and pictures and all the stuff associated with them, and they're all in one spot, which makes it really convenient to get. Now, I've gotten a lot of those things and put them together, and you're going to get that again in the follow-up email. National Air and Space Museum has a Wright Brothers online exhibit that I encourage you to check out. NOVA has an interesting website related to a TV show that they created in conjunction with the Wright Brothers. And then, of course, there's the Wright Brothers National Memorial that you can actually visit if you were in the area. And they've got some curriculum on their website, some articles that you can read if you're interested in bringing some of those literacy components into your classroom. And then beyond the Wright Brothers then, and if expanding on this idea of learning from, in most cases, birds, but there's actually a few different ones. I pulled a number of articles from National Geographic, and these are some fascinating articles that talk about other things that we can start to learn from these animals. And in this case, it looks at owl silent flight and how can we design silent aircraft like the Stealth based off of what owls do. Quieter aircraft is the same way. Seagull wings and how they're designed. The Fanciful Futures has an interesting one. And then one of my favorite ones perhaps is this concept of moving beyond birds and looking at other flying animals, specifically bats, because bats fly in a different method than birds do. Okay, they evolved differently. They evolved flight in a different manner than birds do, and so they do it differently. So, and they're very, very fast. If you've ever seen a bat fly, they're very maneuverable. They move around, they bounce around quite a bit. And so the concept is if we wanted to have an aircraft that didn't necessarily need to go in a straight line all the time and make these broad turns, stuff like that, but we needed something that really needed to bounce around and jut around. They do that largely, especially the insect eaters, because they're chasing an insect. And so they're bouncing all over the place. How do we build aircraft that could do that, or robots that could do that? So now scientists are starting to study bats and how they fly and how we might be able to integrate that into robots and make something completely different. So all of these are some links that you'll have access to. That they're ways to bring in some reading, some other stuff that's going to be included in the email that you're going to get following up. As I mentioned, you're going to get Wilbur Wright's diary excerpt. I think there's about 12 or 15 pages of his diary that you'll be able to go through. What I've done in that diary excerpt is not only giving you the image of the diary so that you can have that, but I've also translated it into regular, I've just typed it out for you in text. So if your kids can't read the handwriting, they can see the text at least, but you can still see the documents in there. I also have the Wright Brothers' original letter to the Smithsonian, which is where they started to inquire about this concept of flight, because the Smithsonian was offering a financial prize and basically some scholarship for people that were able to achieve this. So they inquired. Again, they were not scientists. So they were sort of just putting their name out there saying, hey, look, I'm kind of interested in this. I've been studying toys and things like that. Then they have an article that they wrote called How We Made the First Flight, where it talks about some of the stuff they do. And in that article is where they talk about the importance that birds had in their design. And then there's another fascinating article that came out of, I think, Natural History magazine called The Amazing Albatrosses. And when they talk about albatrosses and their long flight and how they use soaring with their wings, and they have very, very long wings, much longer than the turkey vulture that I showed you. But we typically don't get albatrosses in Arizona, so I didn't use that as an example. Again, you will get those in a follow-up email. And that is all that I have for you. You can always feel free to contact me. Email is going to be one of the best ways to do so. And of course, you can look for additional resources by going to our Focus Wild website, which is our education program at azgfd.gov/focuswild. That is all that I have for you today. So thank you guys for coming out.